1, day 6. We're continuing with our properties of limits. And so we're going to, of course, look at direct substitution being our first go-to. If we can't, we get that 0 divided by 0. We try to write it in an equivalent form. Sometimes what we have to do is look at the right and left-hand limits individually and then check to see if that limit exists or not. So situations where this might come up are in, like example 1 we have here, evaluate the limit of x approaching 4 of x squared times the absolute value of x minus 4 all over x minus 4. So what we're going to do is we're going to look at the left and right hand limits of this. So looking at our left side, so we're going to deal with our limit of x approaching 4 from the negative side of this function of x squared times the absolute value of x minus 4 over the absolute value at x minus 4. So what we have to think about is if we're approaching 4 from the negative side, we are dealing with values less than 4. So when we think about our x minus 4, we're going to have something slightly smaller than 4 and then subtract 4 off of it. And of course, that would mean, of course, it would become a negative value. And that's true for all values to that left-hand side of 4. The absolute value sign will, of course, take hold, and what it does is it times it by -1. So we can have, because it's going to make it positive. So if we force it to, we can eliminate the absolute value sign by timesing x minus 4 by -1. This allows us, of course, now to cancel out our x minus 4s. And we're left with the left-hand limit being the limit of x approaching 4 from that negative side of negative x squared. And of course, this is just a nice polynomial function, so your direct substitution works. 4 squared, of course, being 16, so we end up with -16 as our value. And don't forget, of course, x cannot equal 4 in this case here, since we canceled that out. Now let's look at the right-hand limit. So the limit of x approaching 4 from the positive side of our function x squared times the absolute value of x minus 4 all over that x minus 4. So now, when we're approaching 4 from the positive side, it's always greater than 4. So x minus 4 will always be a positive value. So when we're taking that absolute value, because our solution is always going to be something positive, we would have, of course, just x minus 4. The absolute value, of course, not doing anything because it'll just leave it positive as it is. And of course, once again, now that the absolute value sign's gone, we can actually cancel those values because we know what it is. And of course, we're just left with x squared. Of course, x cannot equal 4 again. And of course, now it's a nice polynomial function. Substituted in, we get positive 16. So therefore, right, our limit of x approaching 4 overall of this function x squared times the absolute value of x minus 4 all over x minus 4, of course, does not exist. And the reason, of course, it's not existing is we have our left and right hand limits not being the same value. Okay, so hopefully we get that. So in certain circumstances, we will have to look at individual right and left hand limits. So let's try another one. Oh, we did this one before. When we have a radical, of course, in the denominator, what we can do, and I'll call it method 1, is what we've done before. Of course, we can rationalize. So limit of x approaching 1 of x minus 1 over the root of x minus 1. We can times top and bottom by the root of x plus 1, its conjugate. And this will leave us with the limit of x approaching 1. In the numerator we'll have x minus 1 times the root of x plus 1 all over the root of x squared, of course, is just x. 1 squared being 1, and we're left with x minus 1. And of course that cancels with that first term. And we end up with strictly the term of root x plus 1. X cannot equal 1, of course. And now, nice square root function. Direct substitution works. We'll have the root of 1, which is 1, plus 1, leaving us with 2. And like I said, we've done this before, where we rationalize. But let's think of a different method. Let's think of another method where, in this case, we know the answer already. What we're going to do is we're going to substitute. I'm going to let u equal the root of x, since that's sort of what's giving us issue. If we square both sides, of course, u squared will be equal to x. That's quite nice. And we can also say, of course, along with that, as x approaches 1 in this case, the square root of 1 being 1, then u will also approach 1. So therefore, really what we're looking at, if we do a substitution, our limit of x approaching 1 of x minus 1 over the root of x minus 1, this will actually become the limit of u approaching 1 all over x, of course, being u squared minus 1 over u minus 1. And notice we have no more radicals. And at this time we go back to our original methods of trying to solve this. Factoring, of course, being a main one. U minus 1 and u plus 1 being our difference of squares up top. U minus 1 on the bottom. Things cancel nicely for us. We're left with the limit of u approaching 1 of u plus 1, where u, of course, is not equal to 1. Let's move that up a little bit. And, of course, nice polynomial function, 1 plus 1, leaving us with 2. And we'll notice, of course, that in both these methods we got the same result, as we should. It's just two different ways of getting to the same result. Where this substitution might come in really, really handy is in those that we have, like example part B. So here we have a cubed root. Now, of course, we can't rationalize a cubed root, because what do we multiply by? We don't know. So this is the giveaway where, of course, we're going to have a substitution where we're going to let u equal that issue we have, of course, being the cubed root of x. If we cube both sides, u cubed will be, of course, x. And as x approaches 8, the cubed root of 8, of course, therefore u will approach cubed root of 8, which is, of course, 2. Therefore, our value of our function, this limit of x approaching 8, will now become the limit of u approaching 2 of the function, the cubed root, of course, being u minus 2, x, of course, being u cubed minus 8. Now, hopefully what that did for you is let you realize that in the denominator we have a cubed difference of cubes. And so we're going to have u minus 2 coming out. What's left, of course, first term squared, opposite sign, first times second, plus second squared, which, of course, 2 squared is 4. And we're left with u minus 2 up top, which, of course, we notice nicely cancels for us, leaving us with the limit of u approaching 2 over function 1 over u squared plus 2u plus 4, where of course u will not equal 2. It's a nice rational function. Direct substitution works. We'll end up with 1 over 4 plus 4 plus 4, or 1/12. And so there, our direct substitution after our substitution of u equaling cube root of x works quite nicely. So what I'd like you to do, of course, is with different questions, we're going to stay with page 45 from the textbook, doing a few more of the more difficult ones with properties of our limits.